Hello everyone, today we'll talk about the solution to the problem longest subarray with maximum bitwise end. Since we want to, from among all the subarrays, first look at those whose bitwise end is the maximum possible, and then report the length of the longest one, then a natural first question is how to find that maximum possible bitwise end of a subarray, what that value actually is. And we can think now along many directions when it comes to determining the crucial observation in this problem. So, for instance, one thing that we can think about is if we have some subarray, then what can happen to the bitwise end if we add another element? And so if we have this end here and we add another element, then can this bitwise end suddenly increase and become interesting? Well, it cannot increase, and in fact after adding this element, this bitwise end cannot increase, and that's because if this bitwise end has zeros at some positions, 1 on some positions, then by the definition of a bitwise end, since, for instance, if we have something like this, we can only have a 1 if both the original bitwise end and the thing that we're adding to it have a 1 on that position. So at most we would have the same thing that we started with, but maybe some 1s become zeros, so we have a 0 here, a 1 here, 0 here, and now this one becomes 0. And of course, if you flip any bit from 1 to 0 in a number, the number becomes smaller. So after adding another element to the subarray, the bitwise end cannot increase, and it can decrease in some cases. So that might be one thing to look at. Another thing to look at might be, and this is essentially an instance of this reasoning, but starting with a single element, which is that if we have an element A, then the bitwise end of all the elements we have is exactly equal to A. Now if we end it with B, then what we get is certainly less than or equal to what we started with, either A or B, right? This can be seen as a special case of this thing, or it can be naturally seen because the result will have a 1 only if A and B had 1s. So the only thing that might change is that some value that was a 1 previously in some of the numbers turned into a 0. So this whole thing is always being determined essentially by the bigger value of those two values. And that means that if we have a subarray that contains the maximum value in our original array, then of course it will have some big bitwise end. And now we cannot get that bitwise end using smaller numbers because the end of any subarray with smaller numbers will be smaller. And also, since we have this big number, the only way for us to get a longer array having the maximum number is if all the values within it are exactly equal to that maximum. And so our problem reduces to finding the subarray that contains only the maximum value in the array and to find the length of the longest subarray that has this property. So to figure out the length of the longest subarray that consists only of the maximum value, we can, in a single pass, both count the number of times the previous element appeared in a row, and also remember whenever we see an end of a run for a given value, if that value is the new maximum or is equal to the old maximum, and in that case we can update the count if the count of the current run was bigger than previously. So in essence we'll be maintaining the value and the count of the current prefix maximum, and the count of the current value we're looking at, which is prev. And also, for ease of implementation, we want to add a sentry to our list, so a value that doesn't exist in the original list, so that we don't have to write this if statement twice. So we go through all the values with our sentry at the end. By using chain, we can go through everything in nums, then everything in this list, which is only a single value, as in a single iteration. And now we'll be incrementing the count of the current element in every step. But of course, our current element might change. So if the element that we're currently looking at is not the same as the previous element, which is instantiated with the first value of our array, then we have to zero out the count. And remember this current element as the element that we're counting. But of course, it's possible that we have just found the longest run for the biggest value that we've seen currently. So if our value is bigger than the previous biggest value, then this becomes a new biggest value. And you have to forget all the counts that we've seen for previous big values, because those values are not the maximum. We found something bigger. And of course, if we should, in this case, update the count, then we look at the current count, the best count. We take the maximum, that is the new best count, and at the end, we can return the best count. And of course, if we didn't have this century here, we'd have to write the logic differently, right? So without this 0 here. Or we would have to take part of the logic and insert it after the for loop in the cases where the longest run of the maximum element appears at the end of the list, because we have to make that check at the end for the last run. Or we can just add the century, then that last run will always end before, as we see that last century, and we will not consider that last century for our result.